Hello once again. So you thought we were done? Well, I've got one more video for you. Once again, I'm going to present an alternative to finding p-values. A lot of the time, p-values are okay. And this is just Mr. Terrell speak right here. P-values are okay a lot of the time, but p-values are very prone to some issues. In particular, sample size issues. If your sample size is too small, that can lead to bias, and you can negatively influence your p-values. And also, there is the issue of you just tweaking your hypothesis over and over again until you do find something that is statistically significant. And so there's actually a term for that. It's called p-hacking, where you play with your numbers over and over again until finally you find something that is just barely significant enough to reject some crazy null hypothesis out there, and you're able to say something that is statistically significant. So p-values in recent years have gotten a lot of flack for that because it is prone to something called p-hacking. So for that reason, I do want to present to you an alternative to finding p-values. One thing was, again, looking at test statistics and comparing it to critical values. We saw that at the end of the previous series on hypothesis testing for means. That's not limited just to testing for means. You can do that for proportions. You can do that for standard deviation. You can do that for variance. You can do it for any unbiased population estimation. So you can still do that here as well. I'm not going to get back into that though. What I am going to get into is another alternative that, once again, you can do not just for this particular form of hypothesis testing, but also for means and for proportions. And that is to build a confidence interval. And you can build your confidence interval using your one sample, or you can do sims. You can run simulations with random resampling or bootstrapping. Or with your one sample, you can build a confidence interval. Now, obviously, I'm not going to get into how to build a confidence interval in this video. I did that in the last chapter, and it took me many, many videos, many more than one. So let me just skip to the good part here. And I got a pictorial reference. So let's say I've got this dotted line here, and this is my claim. I said x is bigger than 3. So x here might be a mean. It might be a proportion. It might be a variance. Let's say I said, oh, let's just make it simple. Let's say it's a mean. Well, it's obviously not a proportion because that's bigger than 1. But let's say it's a mean. I say everyone is at least 3 years old, something like that, on average. The average person is at least 3 years old. So this is my dotted line based on my claim, the average person being at least 3 years old. So I go out and I get some random samples, and I build a confidence interval with, say, 95% confidence, and I find out that I'm 95% confident that the mean age is somewhere between 4 and 6. So that's in here. You'll notice that interval is entirely within my claim, right? My interval is entirely supporting my claim. Well, that's really good, right? I have a full support of my claim. What if instead, though, I got a sample and I was able to say with 95% confidence that the mean age is somewhere between 1.5 and 3.5? Yeah, there's some overlap, but not fully. That's not good. And then, of course, I can be really bad and have no overlap whatsoever. Say it's between 0 and 2. And maybe you're seeing where I'm going with this. Instead of finding p-values, instead of doing test statistics, just build a confidence interval. If your confidence interval is entirely within your claim, your evidence is appearing to support the claim. If it's partially overlapping, well, you can't really say one way or the other. And if it's not at all within the claim, you can say the evidence appears to contradict the claim. All of this instead of p-values. All of this using techniques you already know. And I like that. I like using things you already know. But that's it. That's all I wanted to say about p-values. That's all I want to say about this section. I'll see you in the next. Take care.